Okay. The second approach is to solve for x plus 1. So sometimes it like jumps out at you in this problem. X plus 1 is in the problem already.
Mm-hmm.
So sometimes you can just divide both sides and you're
By
like, oh,
4.
x plus 1 is 4. You don't need to solve for x and then plug it back in.
Huh.
Okay, so this is a time savings thing. You can really shortcut it if you look out for some of this. Now, does it work for every problem? No, but it works for a lot of problems. So we're gonna look at one where it does not work, so you can see the difference here. Or it does not work as well, I'll say. Having a small technology problem this morning, but so there might be a slight delay every time I snip in a question. Okay, so for this problem here, it says, what is the value of x minus 4? So do you see an x minus 4 in this problem?
Whoa.
No. Now, you might think to do the following, like if you subtract 7 from both sides, do you get x minus 4 on the left?
Yeah.
Okay, so if the answer space, and I'll snip in the answers now. Sorry, this is a small delay. I apologize if you hear any background noise.
You're okay.
Okay, so the answers here are numbers. Okay, they're not expressions. So since it's not an expression, like this approach doesn't work that great. Okay, but what you could do, here's what you could do. You could manipulate the equation to get x minus
4.
4. Okay, and you're like, well, how would I do that? Well, if you subtract x from both sides, now you have on the right, you have x minus 2. Now, rather than solving for x, and again, this is a little awkward, but if you subtract 2 from both sides,
You get 1 equals x minus 4.
yeah. Now, is that faster than just solving it straight up for x and then plugging it back in? It's probably pretty close, but this is just another strategy, another tool in your toolbox to be able to figure out, you know,
Problem.
what the problem is. Okay. Now, here's one for you to try on your own. Unfortunately, there's not like a bunch of these that I can give you to try, but here's one to try on your own. I want you to try, instead of solving for x, I'm having that technology problem. Stop, work, please work. All right, here we go. Okay, so here's a problem for you to look at. Rather than solving for x, I'd like you to try getting x plus 1 alone, or figuring out what number goes in the bottom such that when you take 6 and divide it by that, you get 3.
Say that last part again. Sorry, I didn't hear
Well,
you.
it's 6 divided by some number gets you to 3. Like you
6
want to,
divided by 2.
right? So like what you want to really do is like pretend like that whole thing is the variable and that you're circling.
So would I
Yeah.
multiply by x plus 1 to get that out?
Well, you could, but you just said the answer. You just said x plus 1 has to equal 2.
Oh.
I mean, here's an
Oh,
analogous.
okay, I see that.
I
Sorry.
mean, here's an analogous problem. Doesn't really matter what it is. X minus 3 over 20 equals 1/2. What is x minus 3?
It would have to equal 10 then.
Yeah.
Okay.
So
That makes sense.
occasionally you can like grab something out of the problem that like helps you to do it much more quickly. And that's what we're trying to talk about today. So our last kind of problem, actually, here's another one I can give you. Go ahead and try this one on your own, please.
if 3x equals 8y and both x and y are positive. If which following equals 40 yards
40y.
or 40y, sorry.
Yeah.
Would it be C?
So I know why you chose C. Let's try to give you a hint here. How do you go from 8y to 40y?
Multiply by 5?
Okay. So do that for this other one. Do it for the 3x.
Oh, 15.
Yes.
15.
Yeah, you have to do the same thing here to go from that to that times 5. Okay. And like we've talked about a bunch of times, sometimes there's not a lot of writing to do in these questions. You just have to, you know,
Recognize.
move the numbers around. So I think this one is actually more fair to give you to try on your own here. Yeah, we try this one here next.
Divide by 3, so 10 over.
Don't solve it. Try to think about what number goes in parentheses such that when you multiply it by 3 and add 1 to it, you get 10.
Would it be B?
Yeah, like and it's called a substitution. It's like 3u plus 1 equals 10. You know, what is the value of u, or what is that missing piece? Yes, the answer is that. All right, one more. Yes, this one doesn't have any multiple choice, but just it's kind of the same style of question.
If 3x minus 9 equals 6, what is the value of 2x?
For this one, you do have to solve for x first.
So it just bring the 9 over, so it'd be 15, 3x equals 15. 3x equals 15, x equals 5, 10. So it'd be 10.
Yes. All right, not too bad, right? Okay, so now we're going to increase the difficulty of these problems a little bit. All right, 9ax plus 9b minus 6 equals 21. Based on the equation above, what is the value of ax plus b? And if you're like most students, you're just like, I have this is impossible. I have no idea how to do this. But what you might recognize is that ax plus b, it's in the first two terms. Do you see that it's in there?
Yeah. So
What
I
is
could just add
also
6.
Yeah, what is also in the first two terms?
9.
9. So we can write 9 parentheses ax plus b minus 6 equals 21. And now this thing in parentheses, that's your variable. That's the thing you're solving for. 9 times some number minus 6 equals 21.
So it equals 3.
Yes. All right, so this is kind of the true. This is the problem you might see on a test. This is the difficulty where it really does save you time to use the approach that we've been talking about here. Actually make this a little bigger. All right. So it says 3, expression at the top, and they want you to solve for the value of x minus 3. And notice all the answers are fractions. So this one looks really bad. But notice there's an x minus 3 up
The
here.
right side, yeah.
Okay. And this other thing that I'm highlighting, do you see that there's an x minus 3 in there?
Yeah. You just got to divide it by 2.
Yeah. So if you actually factor out a 2, you get x minus 3 minus 11 equals 4, x minus 3 plus 6. Okay. So this is 6x minus 3 minus 11 equals 4x minus 3 plus 6. Now, you've never done this in any math class, but you can do this. You're allowed to do the following. You're allowed to subtract 4x minus 3 from both sides of the equation. And notice what that does is that gives you 2x minus 3s. Okay. And then instead of trying to figure out, well, 2 times what number minus 11 gets you to 6, you just solve it for x minus 3. You just keep going. You add 11, and then you divide by 2.
Yep.
So you get x minus
17.
3, 17
B.
over 2. Yeah. Now, I don't know. I mean, you have to decide if you think you could do something like this on the test. It's like a one-off, a one-time thing that you would need. It's that one play you work on all year that works one time in a game when you need it.
Yeah, I think I could do it. I just need to obviously practice it a little bit.
Yeah. And so whenever you see something that says instead of solving for x, solving for like x plus something, minus something, times something, divided by something, that's when you think about this approach that we've been talking about in these problems today. Okay, so any questions on that?
Nope, that was pretty good.
Okay, just a couple more short ones, but these are, I think, it's a little bit, these are again kind of more difficult, so we're gonna limiting returns on this, but I want you to look at this and just stare at it for a minute or two or a minute and just see if anything pops out, anything.
It looks like they flipped it and then switched to the X and Y.
Okay, now so my question to you is there any way to get 3x plus 2y on the left side?
Cross multiplication?
So you can you can do that when it's in this form, when it's like something equals something with
Oh, okay.
fractions. So your option with this is considered in sort of standard form, this equation that's given, is you can multiply or divide everything. So is there a number that you could multiply it by to get 3x plus 2y?
One half.
So let me show you what you just said. You said, I'm going to multiply everything by 1/2.
Wait, no, because then it'd make it 1/4.
Yeah,
And
it gets smaller.
okay.
So it's got to be a whole number.
Would it be 2 then? I'm not sure.
Okay, well, let's just try it because it sounds like you haven't done this in a while, and that's okay. So 2 times 1/2 is x plus 2/3 y equals 8. So we got to 1x, but we really want to get it to 3x up here on the left.
Oh, we want 3 of the X's, so then it'd be
Yeah.
6.
Yes. Okay, so when you multiply by 6, okay, you get 3x plus 2y equals 24, and there's your answer.
Hmm.
Did you already have practice today?
Yeah, this morning.
Is that
We
a
had
tough practice situation?
it wasn't that bad. We just have like 50 kids out of our high school because they're all sick. So it's like our basketball team is cut in half in our first game. Like our scrimmage is on Tuesday. So we're short a lot of people right now.
Well, are you short the people that you need?
No, nope.
Oh, that's
Just
good.
like a lot of freshmen and sophomore. A lot of underclassmen are out.
And you're graduating this year, is that right?
Correct.
Great. Or the spring. Cool. Okay, so let's look at a new topic here, completely different topic. We're looking at some more, this is line regression lines of best fit. All right, so it says 10 data points are in the scatter plot shown. with a line of best fits. That line of best fit is the actual line that you see drawn. Maybe I'm stating the obvious, but just in case. Which of the following best estimates the predicted value of y when x equals 6.5? So can you try to answer that for me just with whatever you think might be right?
Say A.
Okay, so x is 6.5. There's 6.5.
Oh, I was reading it the other way. My fault. It'd be 16. Sorry.
16, yeah.
I was reading it the opposite way.
That's okay. Yeah, it's why we look at a few of these. That way they're not, unfamiliar. It's like you've never seen one of these problems before. We got to make sure you've got some idea of how to do it. All right, so much like the table problems, much like some of the other questions we've looked at, the actual information contained in these things is not important. Do not get interested in, dimensions of iris petals and whatever iris setosa is, okay? Somewhere you need to figure out what the actual question is asking. So it says, starting right here, based on the line of best fit, if the width of an iris setosa petal is 19 millimeters, what is the predicted length in millimeters of the petal? So you have to decide, are they giving you the X value or the Y value?
They gave me the X.
So they give you an equation too, but you don't really need that. You need to go to wherever that is and kind of figure out where it hits.
So about 52 and a half.
Yeah. Now I don't know if this is a calculator problem or not, but you don't need one either way. Are these difficult?
No.
Like you showed me in the first problem, you have to make sure you know.
You read it the right way.
Yeah, read it the right way. And I know that's the struggle. That's why we're doing these, because it's a small little distinction between them. Okay, take a look at this problem, try it out on your own.
How many of the 9 people have an actual height that differs by more than 3 centimeters from the height predicted by the line of best fit? 9 people differs by more than 3. Height, length of first bone. Differ more than 3 centimeters. One, two, three. Say C.
So you see 6 that are different by 3.
Well, I mean, there's like that group of 4 there towards the middle.
Okay, so
I don't
let me
know if
try
I
to
would
give you
count that.
let me try and give you a hint here. This first point differs by, I don't know, 1, 2, 3, 4, 4.5, 5.
Okay.
Okay, so that for sure is one of them. Okay. And what I do, we've talked about looking at the answers. I look at the answers, I'm like, oh, there's 2, 4. So that one also kind of looks like it's off. So that's 2. And then that one's for sure. So 3, but it's like, well, can I get to 6?
No, but maybe that 4th one there. Would you count that?
Yeah, I think you can get there. I think you can get to 4 pretty. I know this was different than the one I just gave you, but it's not a, they're just asking another interpretation, because they could also say how many are within 3 centimeters. They could, and that could be the other points
That would be
along.
fine.
Yeah. All right, let's look at another problem. This one is more like the ones that we've been doing. Sorry about that. I do try to look, but sometimes I gotta, they're gotta read these really carefully. A lot of words. All right, here we go. Okay. Take a look at this one, see what you come up with.
According to the line of best fit, which of the following best approximates the density of planetoid in grams per cubic centimeter? An astronomer has discovered a new planetoid about 1.2 AU from the sun. According to the line of best fit, which of the following best approximates density of the planetoid grams per cubic centimeter? So it'd be like 4, 5.5, or 6-ish.
Yeah, now I know it's easier for me because I got it right in front of me, but I would always just draw that. That way and you can do that with your finger, just sort of trace it up until you hit the curve and go back on that. All right, so let's do another one more of these, then I'll switch to kind of the other type of questions they ask you in this topic. You will see this again if you take a statistics class in college, which most students end up taking at some point.
Based on line of best fit, what is the predicted height of someone with a first metacarpal bone that has the length of 4.45 centimeters? 4.45 is about 171. So D.
So I think you're being dinged on this one. This is where you're going up and hitting it.
Oh, I went on
And
the other side.
maybe you can't see it because it's just going screen to screen, but it's 4.1, 4.2, 4.3, 4.4. So 4 or 5 is right in the middle there. So I see it as 170. The answers are kind of tight together. It's a tough one to do here. This one should be more straightforward.
Which of the following is closest to the difference between the actual number of home runs and the number predicted by the of best fit in 2003? The scatter plot above shows the total number of home runs hit in Major League Baseball in 10-year intervals for selected years. The line of best fit for the data is also shown. Which of the following is closest to the difference between the actual number of home runs and the number predicted best fit 2003? So what does it mean by the difference?
Yeah, so let's go back and look at this previous problem where you did this. So this was the difference of 3. Like you find the point and you just go straight down to the line or straight up to
Okay.
the line. That's
Okay.
the difference between it.
So it would be for 2003, it'd be what? 5,250-ish to 4,500.
Somewhere in there. Yeah.
So the difference would be 500, 700.
Yeah, you said the right numbers. 5,250 minus 4,500.
So 750, or is
750.
that?
Yeah, 750.
Oh shoot, you wrote it down.
Yeah.
So I zoomed in on the graph.
That's okay. Yeah, it's okay. That's good to do. I mean, this is one of the limitations of this format. I mean, it'd be nice if you had it right in front of you, but you just find the height difference. I mean, they actually gotta allow you to have a ruler on this exam because then you could really hit the line in a better spot. But I actually don't think they allow that. Okay. So a couple more things on regression lines. So if your data goes up and to the right, this has a positive correlation. And you can think of positive correlation as the input goes up, so does the output.
Okay.
The more time I practice with Matthew, the higher my ACT score will be.
Okay.
if you want the analogy to what we're doing today. Okay, but not everything in life is a positive correlation. And it doesn't mean it's bad, but there's what's called negative correlation. And generally it says one thing goes up, the other thing goes down. Okay, so the more that I run, the lower my weight will be. Could be an example. But it could be a negative situation, like the more you watch TV, the lower your grade gets.
Okay.
So there's a third possibility. There's a third possibility, which is that there's no correlation.
Or it just stays flat.
Yeah. Okay. So we try to in real life, do the following, which is completely wrong. We try to say that correlation implies causation.
Meaning?
So you can find two things that are correlated, but it does not mean that one affects the other.
Oh, that it's the cause. That's what that
Yes,
means.
yes, because a lot of things are correlated, like your I don't know, your scores in games might be correlated to like my golf scores, and they're not related in any way, are they?
Okay.
But believe it or not, we could find one. We could probably find a correlation, and it just doesn't happen. It's just unrealistic. So they really harp on that in statistics classes, which you you will take, but you can review this again. So let me give you a question or two based on just the few minutes of notes that I just provided here for you. So this is the most direct question.
Which of the following graphs best shows a strength negative associated between D and T?
So the words association and correlation are the same. They mean the same thing. Which two graphs could it be, in your opinion?
A and D.
That's right. So a stronger means that they are more closely clustered.
So it'd be D.
Yeah, and weak would be
Fatter.
less. Yeah, fatter. Good.
Spread out.
Yes. Okay, now just going back to these positive and negative correlation. For positive correlation, the slope is positive. And for negative correlation, the slope is negative, the slope of the line.
Okay.
And that's important to remember that they're the same. Positive correlation, positive slope, negative correlation, negative slope. It's important to remember that because you may get a question like the following, where you can immediately eliminate a couple of answers based on the sign of the slope. So let me grab that question here. So which of these has a negative slope?
Uh, would it be B? Oh no, that'd be a positive because it's double negative.
No,
So
no,
would it
no,
be
no, 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 you got it. You got it.
okay?
So B has a negative slope, but so does D.
A. Oh, D.
D.
Oh, X is the slope number.
Yes, the number in
Right.
front of X, like B is really the way you want B to be written in standard form is minus X minus 7 or minus 1X. D is minus 1X plus 7.
Okay.
Okay, so what is the difference between those two? What is this other value off to the right? To the right of X.
For the
What is
examples, that would be
yeah,
B. What that would be like
the
the
intercept.
starting point.
Yes.
Yeah.
So where does this graph start?
Plus 7, not -7.
Yes. So which would be the correct graph? Equation, sorry.
D.
Yeah.
Why do they have the 7 in front?
So in regression, they change the order of it. So and this is true in a lot of things that you'll see in college, like I'll give you an example, like in econ economics classes, they teach a variation on calculus, but it's the same as what you get in a calculus math department, but they change the letters and the symbols, but it's actually the same content. And I don't
Mm,
know why. I have no idea why, but that's just what they do. They like to, they want to make it their own, personalize
ew.
it.
That's
But
gross.
it's yeah, it's the same thing. I mean, it's but you'll see that here in the next example. It's the same type of question. Oh, sorry, I'm having a technology issue again. What a
You're good.
nightmare. What a nightmare. Come on, there we go. Okay, so this is the same question as the previous problem. Go ahead and see which one you think this is.
Starts at +6 and it's a negative. So it'd be A.
Letter A, yeah. So like we talked about, I think we talked about standard deviation and range. And you rarely actually need to like calculate the actual line. It's more of like an interpret situation where you just need to be like observing it, what's going on. And it's kind of like if you ever watch another team playing basketball, you figure out who the best player is, but you
And
don't
how it's
necessarily know
playing
their
down.
box score. You don't know that, how many points, assists. You just know, wow, they're scoring a lot, they're distributing a lot, or hey, that guy's really big, so I better, he's probably gonna get the ball a lot during the game.
Just
Um,
observation.
yes, and I think you're seeing that through, through the problems that we've been doing. You're starting to see that it's not necessarily about doing it; it's about interpreting uh, these things. Okay, let me see if there's one more problem here we can do before we switch topics. Yeah, let's just switch topics. Okay. I think we already did those. Okay, here's a new question. So a lot of words again. As always, let's go down to the actual question. It says, what is T? T in terms of P. So we actually have no idea what T is, so we actually have to go back. The figure above shows the distance from Tom's house and from Patty's house to the school on Carver Road. It takes Tom and Patty the same amount of time to arrive at school from their respective homes. Tom rides his bike from his house at an average rate of T miles per hour. Patty rides a bus from her house to school at an average rate of P miles per hour. Okay. What is T in terms of P? So we haven't done a problem like this at all. And I understand if you just feel completely confused. Have you seen this formula before?
Yes.
Do you remember anything about it?
No.
So it says distance equals rate
It,
times time.
okay.
Okay, and the way I used to think about this was if you are driving 60 miles per hour, sorry, that's really bad, miles per hour,
It's a
and you
mile
drive
limit.
for 1 hour, how many miles have you gone?
60 miles.
60 miles. Now you're driving. You've been
Yeah.
driving. Okay.
Yeah.
Okay. So you get on the interstate and you're like, wonder how long it'll take, and you've sort of figured this out. So there's a lot going on in this problem, and I didn't realize this one was this complicated when I grabbed it, but there's two distance equals rate times time going on here. Okay. There's Tom to the school. So for Tom to the school, his distance,
It's
which is
12.
three miles,
Oh,
right? His
So,
distance is 3 miles, but we can write the formula. What is his rate? What is Tom's rate? They give it to you in the problem here.
rate of t miles per hour.
Yeah, so what's bad is R is really T, and then this T, we're gonna have to use a different letter. I'm gonna use X for the moment for his time. Okay, now we'll do the other person, Patty. Patty to school. D equals RT. Her distance is 9. What is her rate?
T
P.
miles per hour.
P miles per hour. And then I'm going to change T to X again. Now, what does it say about their times?
It takes them the same amount of time.
Yes. So we can solve each of these equations for X. X equals 3 divided by T, and X equals 9 divided by P. And then you can set these equal to each other. So 3 over T equals 9 over P. And then when a problem says what is T in terms of P, they're asking you to solve for that variable. So could you solve for T in this problem?
Would I multiply by 3 to bring it over, or what?
You got to get it out of the bottom. So you get it out of the bottom by cross multiplying.
Oh. So it'd be 9t over 3p.
Yes, but just keep going. You got to solve for T.
T 3p multiply by or divide by t. I'm not sure I'd get that out.
Okay, so 3P equals 9T. And which variable are you solving for?
T
So what number is in front of T? I'm sorry, what number is in front of T? I don't know what I said there.
9
9. So you
or
divide
p.
by 9. 9. Okay. So this is
So
not a good
1
choice.
over 3p
Yeah.
equals t.
Okay, now the question I always ask myself when we've gone through this is there a better way that we could have done this? Okay, so Tom doesn't have as far to go as Patty.
No,
Patty has to go 3 times as far.
she's going 3 times faster than he is.
Yeah, and that's what this one says. So we probably could have gotten it down to A and C by using that analogy. And I think you might have some of that, when you're okay, that guy's running down the floor, I got to run really fast. How much faster? Twice as fast, or if you want to catch up to someone. So while the way on the right we did is correct, I don't expect you to remember that. I expect you to use some sort of like comparison between the given information.
Correct.
Because the answers aren't that complicated. The answers weren't like, oh, really sophisticated things. They're just
Simple fractions.
simple fractions. Yeah. Okay, so let's try. I mean, I really didn't mean to grab that problem, but that's all right. So hopefully this one's better. These are grouped weird. So grab another question here. All right, let's go right to the let's find the question here. It says which of the following which of the following is the best estimate of the total number of individuals between 16 and 17 years old in the United States who had a summer job in 2012? Where is that number in the table? Total number of individuals between 16 and 17 that had a summer job in
39.
39. Okay. So 39, well, that means it's probably either B or D. How do we decide between them? Where does it tell you what the numbers in the table?
So I'm not really sure. Oh, 17 million. So it'd be 39 million
So it sounds
or 3.9 million.
3.9 million sounds about right. Let's see if we can do this a little bit more for sure. But yeah, you see how you get it down to those two numbers. So they surveyed 170 people. So it's 39 out of 170, but they said it's about 17 million. So you're multiplying 170 to get to 17 million. And so it's not a million, it's 100,000, but that does get you to the 390,000.
So it would
But
be B.
yeah, it would be, but it's 170 times 100,000 to get to 17,000.
Okay. Okay.
But the important thing is that you were able to get it down to two answers without much effort. And that's, with these ones that are a little bit weirder, it's like, all right, well, what do I do for those? Okay, let's go to another question. We're almost done here. I mean, 5 more minutes. You have to tell me at the end if you want to do a different time each week than Saturday. I'm exhausted by Saturday, ready for something else. All right, if 51-cent coins were stacked on top of each other in a column, I wonder why they can't call them pennies. I guess they don't want to, maybe international students would know it's a penny. The column would be approximately 3 7/8 inches tall. So you got a bunch of coins stacked up, and that's the height. At this rate, which of the following is the closest to the number of 1-cent coins it would take to make an 8-inch tall column? So my question or thought for you is, how do these two numbers compare? How do you go from one to the other,
Um,
roughly?
you'd have to. Could you divide 8 inches by that?
You're going from something that's 3 7/8 inches. So if I write it as a decimal, I think that'll help answer the question. 3.875 to 8.
You'd. That does right. Which was the following
So
closest
hang
to
on a
the
second. Let's say you average 3.8 assists a game, and then all of a sudden you have 8 assists in another game. What would they write up in the paper, or what would your coach say? Your assist total
It's
went
gonna
up
go up
by how much?
2.
Doubled. Like what you've got to see is this is really double this number.
Oh, that's what you're saying.
Yeah, I'm trying to get, because this is more of like number fluency, number sense.
Okay.
Okay, you you had 26 points in one game and 12 in another. Like this is basically double. I know it's not exactly double, but it's like
No, I get what
approximately
you
double.
mean. You
And you have
get
to be
double your
really,
average.
yes. So that means this number is also doubled,
So 100.
100. Now, notice all the other numbers are really weird, like 200 and 390, they're really far away. I mean, if the answers were like, we make better answers here. Let's say the answers were 90, 100. Wow, that's really bad. 100, 110, and 120. Now you have a problem because you actually might need to calculate how much it really is,
Because they're so
but
close.
because they're so close. But since they're not that close, you can, and that it even says in here, closest to, estimate. Whenever you see those words closest to or estimate, you know that you can estimate, judge, what it is rather than getting caught up in the exact numbers. So that's another keyword to look for when you're doing this. All right. Let's go right to the question here. It says, based on the survey results, about how many of the people who saw the movie would have rated it with 3 or more stars?
3 or more, so 17 plus 14 plus 19.
Yes.
So about 50.
Yeah. So notice you don't even need the number because it says again, about how many means estimate, approximate. You don't need to get it exactly. Yeah, let's look at another one here. All right, Jennifer bought a box. I'm sorry, I'm doing the wrong thing. Which is 5%? Which is 5% of the daily allowance for adults? I'm sorry, no, I don't know why that's there. Sorry, let's go over here to the right. How much super grain cereal is in 1 cup of the mixture?
How
All right,
much super grain cereal is in 1 cup of?
yeah,
Uh,
let's read this from the start. On Tuesday, Jennifer will mix crunchy grain cereal with super grain cereal for her breakfast. Super grain cereal provides 240 calories per cup. The total number of calories in 1 cup of Jennifer's mixture is 270. How much super grain cereal is in 1 cup of the mixture?
half, or is it saying more?
How much? It's just saying how much. Um, yeah, this is not a good question. Let's skip this. All right, let's look at, this will be our last question here. It's just totally something a little bit different.
Sorry.
I'm sorry for giving you that question. That was not a good one. Okay, 2 data sets are shown. Okay, data set X and data set Y. If a number is selected at random from data set X, what is the probability that that number is also in data set Y? Okay, so what they're asking you to think about is there any overlap between the 2 data sets?
There's 2 5s in X and 1 5 in Y. There's no 4 in X. There's no 2 3 in Y.
So how many
There's an
numbers
8.
are in both?
5. Like 5 different numbers. Is that what you're
Sorry,
saying?
I didn't ask that well. 2 does not appear in Y.
No,
3 does not appear in Y, but
no.
5, 5, and 8
And
do.
8 do.
So there's 3 out of how many data numbers are in data set Y?
5.
5. Yeah, there it is. Now, if we were to go the other direction, let's do that here, that we will actually finish here after this. Let's say we're going the other direction. So how many, so we'll just switch the letters here.
2/5.
Yeah, so those are both in there, maybe 2/5. Very good. Okay. Thank you for letting me help you today, Elijah. Do you want to continue doing Saturdays, or do you want us to find another day time each week?
Well, what works best for you? Because I can't go from 3 to 6, and then I'll most likely have games every single week on Tuesdays and Thursdays, and I
Yeah, I
have
was looking at
church
your
on
schedule.
Wednesday.
Yeah, I was looking at your schedule. So Mondays would be possible as a regular time, potentially. If you don't like Saturday, Saturday's fine with me. I had other appointments today,
Sorry?
but Mondays at 8 your time would be doable as a regular time. Let me just look real quick. Let me stop sharing. Do you have a few minutes for us to stay on?
Yeah, go ahead.